Hello, good day viewers. In this tutorial, we are going to apply the knowledge of definite integral that we have to derive that formula used to find the area of a cycle. Let's get started. A cycle is something like this. Okay, I would like to draw a cycle on a grid from the origin. Suppose we have y-axis and we have x-axis like this. So from the origin, I would like to draw a cycle. This is my cycle. And you know that from the center of a cycle to any part of the circumference is called the radius. So this line from the origin 0 to this point is r, which is the radius. And I can determine another radius from the center to any part of the circumference. So let me call this one radius again. You know that this is y-axis and this is x-axis. So I would like to use the first quadrant. Find the area of the first quadrant, then multiply by 4 because we have 4 quadrants in the cycle. 1, 2, 3, 4. So let us concentrate on the first quadrant, find the area, then we multiply by 4. So if we should form a right angle triangle here, you know, this is our angle of reference. Let's call this x and let's call this y. I would like to establish a relationship between x, y, and r according to Pythagoras' rule, which stated that y squared plus x squared is equal to what? R squared. Now I would like to make y the subject here. Let's take this one to the other side. We have y equal to r squared minus x squared. Remember to take square root because we have to take square root of both sides in order to eliminate power of 2. And we don't have to attach plus or minus. Remember, in the first quadrant, both y and x are all positive. All right, this is what we have. And therefore, if we should integrate y with respect to x from 0 down to r, we shall obtain the area of the first quadrant, right? So area is equal to the integral from 0 down to r of this function, r squared minus x squared with respect to x. Now I would like to form another equation with respect to x and theta. What is the relationship between x, theta, and our radius? Remember, according to our ratios, trigonometric ratios, this x can be obtained by taking what? R multiplied by cosine of that angle. Now let me differentiate the left and the right hand side. The moment you differentiate this, you shall obtain dx, right? And this is equal to, remember r is constant, so we are only differentiating with respect to theta, and once you differentiate cosine, you get negative sine. So this is negative r sine theta d theta. And from here, if I should square both sides, or let me do that down here. If I should square this, I have x squared equal to r squared sine, okay, cosine, sorry, cosine squared theta by squaring both sides, because I realize I have x squared here. I want to back substitute. So let's continue from the other side. So here we have our area to be equal to the integral. Forget about the boundaries because they are going to change. Our initial function is in terms of x, but now we want to change it to be in terms of theta. So we have the square root of r squared minus x squared, but this x squared is now r squared cosine squared theta. R squared cosine squared theta. Dx is now what? Negative r sine theta d theta. So I can bring the negative outside here before the integral. Then we have r sine theta d theta. All right. I would like to simplify the square root before we continue. If you have a square root of r squared minus r squared cosine squared theta, I can write it as the square root of, we have r squared in common. So we have r squared in bracket. From the first r squared, we have 1 minus. From the second term, we have just cosine squared theta. But what can you remember about 1 minus cosine squared theta? Remember, if you have sine squared theta plus cosine squared theta, this will give us 1. So what about making sine the subject? We have sine sine squared theta will be equal to 1 minus cosine squared theta, and you can see we have 1 minus cosine squared theta, which we can simply replace with sine squared theta. So this is the same thing as square root of r squared, but instead of this we write this one, sine squared theta, and this square root and these two powers will cancel, leaving only r sine theta, right? So the whole of this square root is r sine theta. Let's continue. A is equal to negative integral of r sine theta multiplied by another r sine theta, then d theta. Let's multiply. From here we have our area to be equal to negative the integral of r squared sine squared theta d theta. Remember that r squared is constant, so we are only integrating sine squared theta. But before then, I would like to bring back our boundaries. Remember, we started with from 0 down to r, which are in terms of x. But since we're in terms of theta, we have to change the boundaries. And what is the relationship? Just look at it here. We have, let me write it here. We have x equals r cosine theta. Initially, the lower limit is 0. So what if we should plug in 0 here? We have 0, that is when x is equal to 0. We have 0 equals r cos theta, right? If you divide both sides by r, you have cos theta equal to 0. And cos of what angle will give us 0 from the first quadrant? It is what? Cos of pi divided by 2, which is right here, which implies that theta is equal to pi divided by 2. So we are going to replace this with pi divided by 2. And what about the upper limit? That is when we have x equal to r. So when x is equal to r, we substitute it. Here we have r equal to r cos theta. By dividing both sides by r, we have cos theta equals 1. So cosine of which angle is equal to 1? From the first quadrant is cosine of 0. So we have 0 right here. And remember, since we have negative outside from the lows, we can make it positive and switch the limits. Take this one to the top and bring this one down. So this is area equal to now the integral from pi divided by 2 down to 0 of, I can bring the r squared outside since it is constant. We only have sine squared theta d theta inside. So this is what we have to integrate, sine squared theta. I don't have to show you all the steps. I have a particular video that showcases all the steps for finding the antiderivative of sine squared theta. I think I'll place it in the comment box or in the description. So A, which is our area, is equal to r squared multiplied by the integral of this will give us theta divided by 2 minus sine 2 theta divided by 4. The limit is from 0 down to pi divided by 2. So now let us first of all plug in the upper limit, which is pi divided by 2. This is equal to r squared multiplied by theta is now pi divided by 2. If you divide it by 2 again, it will give us pi divided by 4, right? Pi divided by 4. Then minus, plug in pi over 2 here times 2 will give us just pi. And sine of pi is 0, divided by 4 is 0. So everything here will be 0. And you don't even have to substitute the lower limit, because plugging 0 here will be 0 over 2, which is 0. Plug in 0 here, sine of 0 is 0, divided by 4. Everything will be 0 if you plug in 0. So even this one will be what? Our area for the first quadrant is equal to pi over 4 minus 0 is still pi over 4 times r squared. So that is pi r squared divided by 4. This is our area of this region alone. But since we are looking for the entire 4 quadrants, we have to multiply by 4. So let me do that right here. Now the total area, let me call it total area, is equal to 4 quadrants multiplied by pi r squared divided by 4. And this will cancel this, leaving only what? Pi r squared. And finally, our area of cycle is equal to pi r squared. You see that? As simple as that. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.